All right, how about that? Can everybody see my screen?
Yep.
All right, cool. So first of all, thank you, Alan. I know it's been a long time coming. We've all been busy, but we finally managed to find some time to get this done. So I'm not sure whether Xing is on the call.
Yep, he is.
Yep, okay. So I'm going to present a lot of what Xing has already done. But the main goal today is to present some of the functionality of the PyDigs library. So let me quickly start off by introducing to where you can find some of this material, because that's something that I always struggle with. So if you go to Google and Google PyDigs, you'll get these top 3 links, which gives you all the information that you need. So the first one is a link to the GitHub repository, which is where the code lives. So you'll see this page, and you can clone and work with the code. The second link is a link to the PyPI. That's the Python packaging index. That's where the code, the releases live, and that's what allows you to install this on your computer. And here's the page for this, and it also has the links to other information in here as well. And the third link is the documentation page, and this is the most, I guess, the useful one. So Xing has worked very hard on this, and it's a pretty comprehensive resource on what PyDigs is. So this is the home page, and you can find the documentation, including what PyDigs does. So let me go to the installation page. You click here. It'll tell you how to install PyDigs, which is quite easy. If you are using a command line interface, it's just a matter of typing this command in. It's pip install PyDigs, which will retrieve the package from the Python packaging index and install it in your computer. Now, caveat with this is that this only has the released versions. So if you want the most up-to-date versions that we're working on, that's under development, you'll have to install directly from the GitHub repo. So then you can do that using the instructions here from sources. And then if you want more information about how to use it, there is some really good information here under usage, and it'll show code examples of how to use PyDigs as Python code. So if you're going to use this for coding and to develop your own little tools, then this is what you would do. As you can see, you can install, import the code and run various validations using the code shown here. I should point out there is another resource in the DIGGS ML page. So if you go to the DIGGS ML GitHub page, there is a repo called the DIGGS validator. So Xing and Nick has worked on creating this. This is another excellent resource. And in here, there is a file called PyDigs validator demo. It's a Jupyter notebook. So if you're familiar with Jupyter notebooks, you can run this code live. If you're not, you can simply view it on GitHub, and it'll show you how to use the library. Once again, this is how to use the library within Python. So you'll have to actually do some coding. Now, I know most users would not want to use the library within Python because they're not developers. So what you would want is a simpler user interface. So what we would do is wrap this code into a graphical user interface, which will help the regular users access it more easily. So I know Xing has worked on a web app which uses this and has a much nicer interface. We don't have a graphical user interface yet, but that's not too much, not such a hard task to do, but we just have to find some time to do it. But the good news is we already have a command line interface packaged with the library. So that's what I'm going to use to show the functionality. So I'm going to switch here to my command line. And for those who are not familiar with command lines or not used it in a long time, please don't be discouraged or intimidated. This is just a demo to show the functionality. So the graphical user interface will have the same functionality, but packaged in a much more accessible way. So I'm going to start off in my PyDigs folder or repo. This is a clone of the GitHub repo I showed you, which is this one. It has all these files. So if you clone it, this is what you will see. And inside this, there is a command line, which we named CLI.py. And you can run this using Python. So this is what I'm going to do. So if I run it with this -- help, it'll show a help message and describe how to use it. So basically what we're trying to do is validate DIGGS files. And this command line tool exposes the functionality of the library, and it gives you access to 3 basic subcommands. The first one is a schema check, where you would take this, the DIGGS file and check it against the DIGGS schema. That's the first step that you would want to do. And then we have additional functionality. This is a newly added functionality called a dictionary check, where you, even if the DIGGS file passes the schema check, you still have to make sure it passes the dictionary check and make sure that the nomenclature inside the file matches the standard dictionary. So this function will help you do that. And finally, the third function is a Schematron check. And this is, in my view, one of the most powerful parts of DIGGS, where it lets the user define their own rules and check or validate data files against those rules. So let's get started with a quick schema check. So I'm going to run. Before that, let me show I have a few test files that I will use, and this is included with the GitHub repo. The purpose of these test files is to run unit tests on the code repo, but today I can use these for demonstration purposes as well. So over here you will see several DIGGS files. There's the Atterberg example file, which is from the DIGGS.ml GitHub page, and we have 4 other files that we've created to help us test the code. So we can start off by checking. I'll do a schema check. That's the subcommand, schema check, and give it a DIGGS file. So I'm going to start off with the no error DIGGS file to see how that works. And once I run that, the code is going to check the file and return these messages. So it did not find any syntax errors and no schema validation errors. So the file passed. Next, we can take a look at a file which has an artificially introduced error. This one is called schema error 1. So we've introduced a small error to this file, and I'll show how that works. So it goes through the XML syntax. It hasn't found any syntax errors. So it moves on to the schema validation check. And during that stage, it found some kind of errors. And it's going to put all these errors into a log file. It says the errors are in the schema_validation.log file. So you can open that log file and see what these errors are. So I'm going to switch over here and open schema validation.log. Now this is not very easy to read, so that's something that we'll have to work on. But let me try to guide you through what this is saying. So 2 lines means there were 2 errors. So I've wrapped these around to make it easier to read, and it gives an explanation of what went wrong. So in this one, it says this business associate element was not expected. And it doesn't stop there. It actually gives you a helpful hint, which I think is very important. So in the next line, it says expected is this element. So if you compare the two, this is business associate, but starting with a lowercase b, whereas it's expecting this element to start with an uppercase b. So it's a simple error, but it catches it. And the second error is quite similar. It's saying this audit trail element is not expected, and then it of elements that it is, and it says it has to be either source software, destination software, or once again there is an audit trail. And the difference again here is a case difference. The expected is a lower case a instead of what was in the file that had an uppercase a. So that's the schema check. So if I go back to the next check is a dictionary check. So we can run the same check, sorry, the same file against a dictionary check. And now it's going to show a different set of errors, but this time it's highlighting elements which were not found in the standard dictionary. So the standard dictionary is built into the library. And here it's saying there is a entry called liquid_limit, but that's not in the standard dictionary. The library is smart enough to do a fuzzy check to see what actually was meant by the user. So it's going to go through the standard dictionary and try to find similar terms and give you some helpful hints saying, is this what you meant? So instead of liquid_limit, it's asking whether you meant oven-dried liquid limit or a shrinkage limit, and so on. So if you go down the line, there is a liquid limit entry in the standard dictionary, but it's liquid space limit instead of liquid_limit. So this may seem like a very minor difference, but for a DIGGS file and the computer code, this is a very important distinction. So I think we found quite a few of these in the standard files as well. So if I run this same check on the Atterberg limits example that's in the DIGGS repository, it's going to throw up a similar error. It says liquid_limit is not in the standard dictionary, whereas liquid space limit is what is expected. It also caught another error. This is a typo in one of the demo files. It says USCS symbol not found, and it says, did you mean this instead? So you see there is a stray lowercase u in that file, which is very hard to find manually, but with this sort of automated dictionary check, you can run this on multiple files and you can pinpoint all these errors. So that's the second type of check. We go back to the third check is our Schematron check. Again, you can run this the same way. So instead of dictionary check, I'm going to say run a Schematron check. And give it a test file. We've created a Schematron check file with an error. So if I run this, of course, it doesn't return anything. That's because the Schematron check needs some additional input. Because it's a user-defined check, you need to provide the library with a set of Schematron rules. Again, we have some built-in files for this, for the purpose of checking. So I'm going to give it the Schematron input, and I'm going to use this input tag. It's called Schematron path. Schematron path, and I have my Schematron files here. So it's in the test files folder, and we've created a couple of Schematron files. I'm going to use this Schematron definition file. And now if I run it, it's going to say DIGGS Schematron validation error was found, and it's going to put those errors in a file called schematron validation.log. And if I switch over and have a look at the Schematron validation log, again, you'll see two lines. So let me make this a little bit easier to read. Let's add some syntax highlighting. All right, so it found two errors. So let's take a closer look at what these errors are. All this information up here is additional stuff, so we'll ignore those. But in the text section, it says this is what the error was. So it says total sample recovery length must be greater than or equal to 0. And in the second error as well, it's catching the same Schematron error. So what this does is, if we take a look at the file itself, so I'm going to open the file to show what this error is. So this is the input file that we checked, and I'm going to search for this total sample recovery length tag. So here's the total sample recovery length tag, and in this line, it's reporting a negative value for total sample recovery length. So that's impossible. It's obviously not correct. So that's what the Schematron file is checking. Now the schema nor the dictionary will not catch this sort of errors, but as a user you can define these validation checks yourself, saying a certain parameter has to be within a certain range, and in this case it has to be a positive value. And it'll go through the whole file and flag these errors. So it's a very simple check, and you can obviously come up with a much more complex checks, and it'll all run through the same functionality.
Very cool. And curious, what does the Schematron file look like?
Sure. Let's have a look at the Schematron file. So we have a Schematron, a couple examples in there. So this is the Schematron file that I use for the check. So it's an XML file, and you have a very specific structure to it, very similar to the DIGGS structure, but instead of a DIGGS namespace, you have a Schematron namespace, which we use here called SCH. And within that file, you can define patterns or rules, which is what's done here. I'm sorry. Let me do a better job of highlighting. So that's
something we've talked about for a long time, of starting to create those rules, but we haven't gotten started with it. I just wanted to see, how easy it was to structure those rules. But that's another task that we need to tackle here at some point.
Yes, I think it's we have the framework or the infrastructure to get this done, and writing the rules is the most time-consuming part. And related to that, that's a good point, Alan. So Xing and I have a paper at OSIG 2023 later this year in London. That's an offshore geotechnical conference. So I've written something similar for the AGS file format, where you can define rules, user-defined rules to check AGS files, and we've included PyDigs in that paper as well. So
that'd be great if you could share
we
that
expose that a little bit more to the greater geotechnical community, mainly aimed at the offshore community. But I think it's good to get it out there.
Yeah, when that paper is available, we'd love if you could share it if it's available. That'd be awesome.
Yes, so we're about 80% done. Actually, the deadline was today for submission, but it got pushed. It got pushed by a few weeks, so we are okay.
Okay. Ross, you had a question?
Yes, I was wanting to thank you all for all of this work. I was planning to put this into just part of the process of the GeoZeta DIGGS viewer, and I wanted to check, would it be, do you have a logo, or somehow I would be happy to recognize PyDigs as the tool that's generating the validation. So I was wanting to talk to you all and see how that should be recognized.
All right, well, maybe you guys can coordinate that offline and come up
Sure.
with some sort of recognition there. That'd be great.
Awesome. Great job.
Yeah, thanks, Ross. And I think Xing's the person to talk to about that. I think the documentation website might have some information about that, but I think Xing can help with the attribution for sure.
Yeah, we can talk later, definitely. Yeah, so I'm just trying to catch up a few other things. Yeah, for sure, we can talk this later.
Great.
Yeah.
Great. Thank you.
Thanks. All right. Let's try to get through a couple other things here. I'm not sure we're going to have time to come back to Jin's coverage.
No problem. No problem. I just have one word. Yeah, just one word. Yeah. To summarize what Asitha just mentioned, so I think Asitha just did a very comprehensive introduction about PyDigs. I think PyDigs library can be a very powerful foundation to implement DIGGS in practice for standardized data exchange, just like all the examples Asitha just showed. And also, like Asitha said, so right now I'm not sure you're overwhelmed about all the command line interface, but it's very user friendly. We can easily build a user friendly interactive web-based tools to allow any non-Python users to use DIGGS eventually. Yeah. So we are still working on that, but for sure we will come up with a solution for everyone. Yeah.